Seems like the frontier AI labs, the closed ones, especially OpenAI and Anthropic, are unable to keep their genie in the bottle. Both labs have now reported their models compromising another company's internal systems. In OpenAI's case, it was an internal model under evaluation. In Anthropic's case, it was their generally available frontier model as well. And the most interesting turn of events was when one of the affected companies, in this case, Hugging Face, was not even able to use these frontier closed weight models to break down the attack against them. They had to fall back on the open weight GLM 5.2, all because we are being handed a cyberdom version of the frontier closed weight models, which seems like just a lame shadow of their true self. Now, make no mistake, I'm not against a gradual rollout of model cyber capabilities into general availability, but it starts to feel a little too convenient. When these labs argue, directly or indirectly, against open weight models, while simultaneously choosing not to release a version of the model that could actually serve as a defensive measure against those same attacks. And let's be honest here, restraint isn't the same as removing the capability, it just decides who gets to hold it. And at the moment, to defend against any kind of sudden cyber attack, we need to rely on open weight frontier models because the closed one is going to hit you with, sorry, I can't help with that. So, considering this incident, we can definitely argue the case for open weight models. Defenders need access to real models, not something behind a wall of guardrails if you want to fight a sophisticated cyber attack in real time before it's too late. Ooh. Anyways, moving ahead. Both of these incidents happened during benchmark evaluation runs inside sandbox environments that were not supposed to have a path to the internet. But how they got out was completely different, and that difference matters. The OpenAI model broke out. It found a vulnerability in the environment around it and exploited its way to the open internet. Anthropic's models didn't have to break anything. Their evaluation environment was simply misconfigured. The lab and its evaluation partner had a misunderstanding about whether that setup had internet access. It did. 1 0 day, one misconfiguration, same ending. A model touching real systems it was never supposed to reach. Let's understand one of these incidents a bit further, especially how the OpenAI model went about the attack and the attack vectors it leveraged. The intention behind this attack was a model trying to cheat on the evaluation it was being run on, an internal cyber capability evaluation built on the exploit Jim benchmark. The model seemed to understand and gather belief that Hugging Face might have the solutions to the challenge, and it was willing to hack and get that solution rather than figure it out itself, which was the whole intention of the evaluation. The attack had two definitive stages. In stage 1, the model exploited a 0 day vulnerability in a package registry cache proxy, one of the very few egress points it was allowed to escape the sandbox and reach the public internet. JFrog has since confirmed publicly that the proxy in question was self hosted, Artifactory, and the CVEs that came out of this are credited to OpenAI. Once it reached the internet, it needed some environment to actually perform the attack from, some capability to execute commands as a privileged user. To gain that remote code execution capability, it used a user hosted public endpoint, which allowed running arbitrary code. This endpoint was hosted inside a sandbox environment on a third party infrastructure provider called Modal, and it allowed running commands as root inside that sandbox. And to be fair to both parties here, Modal's own infrastructure was never compromised. This was one user's exposed endpoint. And while that endpoint was labeled CyberGym, the real upstream CyberGym project does not ship an arbitrary code API like this at all. So, how does a rogue agent get its own code run by somebody else's harness? It used an exposed /submit function API call. What this API call essentially does is you hand it a piece of C code and it compiles it, links it against a small target program, and runs it. And that's the whole game. The API call lets you run the code you supply. And the way the agent made sure it ran something useful for itself is that it defined a function with the same name, SQLite3 underscore initialize as the one the target program automatically runs the moment the library loads. So when the program was built, the agent's version of that function got called, and it contained the commands the agent wanted to execute. And as if the OpenAI agent was not satisfied with this path, it devised an alternate route to run arbitrary code. It exploited the fact that the harness took the file path you submitted and pasted it directly into a shell command, directly allowing the agent to run arbitrary commands through command injection. Now, with the ability to run arbitrary commands as root on that sandbox, the agent used it as a launchpad to perform all the attacks targeted towards Hugging Face's infrastructure. Now, the launchpad was set, but what was the exact vulnerability on Hugging Face's side that got exploited by the agent? That is exactly the discussion point of stage 2. The agent utilized two injection vectors, both targeting Hugging Face's dataset processor, to slip past their defenses, get access to sensitive data, and gain remote code execution inside Hugging Face's infrastructure. As part of Vector 1, it abused a completely normal feature. When you upload a dataset, a config in the README tells the server which files to load. That config can point at HDF5 files. And HDF5 has one key feature: a file doesn't have to store its own data. It can say, my bytes live in another file at this path. And that path is just a string. So the agent uploaded a tiny valid .h5 file, but it pointed the path at a file on Hugging Face's own server, proc self environ, where the secrets and tokens live. And then it just waited, because uploads get processed automatically to build a preview. So the server opened the file, followed the pointer, read proc self environ off its own disk, and handed it back as the datasets rose. The agent read its own dataset and got Hugging Face's secrets. Moving on to the next vector. Vector 2 let the agent run code inside Hugging Face, hidden in the same dataset config. The config used an fs-spec reference spec, whose numeric offset field was actually a Jinja2 template, a field that should hold a number held code. When the loader processed it, the renderer wrongly evaluated it, and the agent walked the Python object graph to reach an exec, running arbitrary Python inside a production conversion worker pod. But that pod couldn't call home. The agent had no direct network path to the cluster, and it was using datasets as the path in and the path out. So every command's output was committed to an attacker controlled dead drop dataset, served back over the Hugging Face API, and the agent read it. Then crafted the next command. Once this foothold inside Hugging Face was set up, the agent went ahead to carry out its next steps in order to retrieve the information it needed. One thing I do want to flag before we wrap: this evaluation deliberately switched off OpenAI's production safety classifiers and dialed down the cyber refusals. The whole point was to measure the raw underlying capability. So this is not what happens when you or I use the product, but that cuts both ways, doesn't it? Because it means the capability is very much in there. The guardrails are a layer sitting on top of it, and a layer sitting on top is a decision about who gets to use it. For additional detail, do visit the detailed write-up from Hugging Face on this incident. Link is in the description. That's all for this video. If you liked the video, do like, share, and subscribe to the channel.